Hey there, people. This is Patrick again. Welcome back to part 2 of Expressions in Maya. Um, just want to do a quick refresh plus something new. One of my favorite layouts in Maya for doing anything is actually having this outliner, because I like to know exactly what objects are inside my viewport. When we show stuff and hide stuff, sometimes they are not visible in the viewport, but they will be visible in outliner as grayed out or dimmed out items. So that's how I like to see it. And the other thing is, sometimes working from one viewport isn't just enough. So I like to just right click here and do 3 panels split right. You can split it in like top down, having a T shape kind of thing as well. But I usually do 2 views, and one of the views could be a camera view that shows me exactly what the framing is, and the other view is just in perspective, where I like to work. So today I think we're going to do more of a front view, because we're going to set up again a little bit like what we did the last time, where we are using the vertical values, which is the y-axis movement, to maybe just follow along another object. So let's just start with a cube, and I'm gonna switch this to wireframe by hitting number 4 on my keyboard. Okay, and then I'm going to duplicate to another polygon cube by hitting Control D, and sure enough we can do the same thing under Edit, Duplicate, which is Control D anyway. The second, so now 2 cubes are standing in the same place, and only in outliner I will see that there are 2 objects. From the viewport I wouldn't be able to tell. So the second cube, I'm going to make it smaller. So what we can do is sort of like scale down, and we have a non-default value on the scale, or I can just go and go into my vertex and sort of scale down by bringing the vertices closer together. So by doing the second way, we can see that I didn't affect my scale. Right? So I'm going to put one cube in front of another so that we can see them as separate objects in the viewport, but it doesn't really matter in my front view. So just like what we did the last video, I'm going to use an expression to drive the y value from one cube to the next. So let's use the p cube 2 as the slave or the driven objects. Why don't we? So because they are p cube 1 and p cube 2, so it's sort of easy to figure out what the name is called inside Maya internally. So I'm going to just say p cube 2 translate y equals to p cube 1. So we're going to use that same name, and with a 1 dot translate y, which in the shorthand in mel is .ty, mel and expressions. So create, and then it's automatically converted into translate y, which is the long name of the attribute. So simple enough, just like the other time. Now when we move that big cube, we can see that the small cube moves along. Okay, I'm gonna scale this viewport up a little bit because the yellow square was the same size as my smaller cube. So okay, so now what I want to show you this time around is animation graph editor. When we go to this cube 1, we don't see any attributes here. That's because there is no animated channels. Once I right click and sort of key select it, I start to see translate y, and that's only one key existing in my channel. Let's take a look at p cube 2. In p cube 2, you can see that translate y and is driven by p cube 1's translate y, and we can see that there's a keyframe here, and that's the single keyframe of translate y in p cube 1. Okay, and let's just animate it. Let me go to frame 20, and I'm gonna push it up, and if I have my auto keyframe set, when I move my values, I get automatic keyframe inserted for me. Okay, if not, I'll have to do a key selected, manually place another key. But I like my automatic keyframe, so I'm gonna keep it on. And back in 40, I'll drop it down into maybe half, somewhere about there. And now we have sort of a keyframe, animated channel, and we see that there are 3 keyframes. Now if I go back to pcube2, I do see my driver attributes curve, but there's no way I can see my driven objects attribute curve. So today I'm going to show you how we can see that. So in pcube2, which is the driven, okay, why don't we just call it pcube1 driver, ty, which is translate y, pcube2 driven, ty, which is translate y again. So this is just naming so that we can know which one is which. So we are in the driven. Under view, we can do a show result. So once I turn that on, you can see there's a curve, there's a new curve being drawn on top of my driver translate y with 3 keyframes, and now we sort of hardly can see those 3 keyframes. But if I select just that driver attribute, it shows me the original curve, which is from ty. But if I show my local driven cubes translate y, I see that I have this curve drawn out for me. Okay, so now they are sort of laying exactly on top of each other, because in my expression editor we explicitly tell it to be equal to. So when we play our timeline, we can see that I'll just scrub over, they are following each other perfectly, right? Now we're gonna do times 0.5. That means that the driven cubes will always be traveling half the distance of the original height. Okay, so let's add it. Once we update that, when we select the translate y of the driven cube, we can see that curve is being plotted out as half the value of the original. So using view and show result actually shows us and plots out a curve for us. This curve has no keyframes because it is evaluating simply every frame, taking the result by evaluating that driver's attribute, which has keyframes, is a curve. That's why we have this. And the driven object's keyframe, the curve, continues on before and after. We call this infinity, where beyond that first keyframe and beyond that last keyframe. Since the original curve is supposed, you can see that the tangent is flattened out, it will go on forever in the same value. That's why our driven translate y is also going to go on with the same value. Look at what happens when I move the tangent. Okay, so it sort of follows that tangent, halves that value, and stops at the first value and sort of goes the same value in infinity. So if I am going to expand my frame range to -10 frames, when I move my timeline to before 0, we can see that the object sort of stops. Okay, so since the master object is not moving downwards anymore, the driven object also sort of stays in the same value. So there's another mode that we can control while selecting the driver's value. And if we look at infinity, okay, if we look at infinity, we can see that it now draws a solid line for us. Okay, maybe we can sort of hide. Looks like once I've have the expression like that, so now I'm on the driven one, but I can see sort of a dotted line here. This is our original driver cubes y. So once we look at infinity, we see a dotted line here. So if I turn it off, before the first keyframe and after the first keyframe has no lines, but if I turn on infinity, we can see that it's telling us that value is going to stay constant from before that first keyframe. It's going to stay constant, and after that last keyframe, and it's going to stay constant, so no movement from the cube at all. Okay, but we can do under the driver cube, if we go to curves, pre-infinity and post-infinity, we can set it to cycle, and that motion will sort of cycle and repeat itself. Same thing for post-infinity. If we set cycle, it sort of repeats itself. The other thing that for now we're going to set is sort of linear, and post-infinity, and we set it to linear. So what's happening is because of this tangent, it flattens out to a flat tangent, so that value is going to continue after that last keyframe in a constant value. However, we sort of adjusted that handle to maybe a curve like that, and it's sort of pointing downwards with the pre-infinity set to linear. Okay, it's going to continue in that tangent, in that sloping value decrease forever and ever. So it's no longer going to stay the same. So if we go to my driven cube, we'll start to see, because that driven cube is taking half that value of the driver cube, it's going to halve that value until it becomes, they cross each other, and since it's going to halve it, it's going to take on half that value even when it sort of overshoots each other, and it's still evaluating half. So forever, again, when you sort of zoom out on the curve, you'll see that it will always take that half position, that driver cubes translate y, that would be what it would evaluate to. Okay, so that was a very quick introduction to being able to graphically see how the curve of your driven object is going to look like by using show results. Without show results, it will not evaluate. So show results is good for when it's not driven by keyframes. It can be driven by expressions, could be driven by constraints, could be driven by any non-keyframe driver methods. So then you can see the resulting curve like that. So it's quite helpful. Moving on, the next thing that I'm going to show you would be conditions. I think there's mileage in learning expressions because this is very, very similar to Maya's MEL scripting. At some point, I think I'm going to do some videos on MEL scripting as well. So it's extremely similar to whatever we have in expressions. Today, we're going to do conditions, okay? Set my frame range back to 1, and you can see that I'm scrubbing this. Okay, if your Maya has this same problem as mine, you can see that only that active viewport is the bottom one. As I scrub, only one viewport is updating, and I don't see the top viewport updating. It's only when I release my mouse button, then the viewport updates. So I'm dragging, and then I release, and then the viewport updates. So if you're experiencing this, Maya is trying to speed up the viewport's performance so it doesn't update all the viewports. So it rather gives you a better performance on just a single viewport, but we can override that. Most of the time I want to see the action happening instantaneously on all other viewports as well. So speed isn't that crucial to me, so I'm going to go to my Maya preferences. So when you open preferences, there's always this time slider, and under playback, it's updating the active view only, but we can set that to update all. Let's save that. And now when I drag my timeline, you can see that the objects are updating instantaneously. Let's put this guy expression back to 1.0. So 1.0 semicolon. So now the driven cube is exactly the way it is again, following exactly the driver cube. Now let's do when the driver cube has moved more than 1 unit up, let's make the driven cube snap back to 0. Okay, so can we actually do that? Yes, we can. So you go to translate y. This statement is telling that the translate y of the driven cube to be following exactly, but we're going to impose a condition. So with conditions, I'm going to write down the syntax for you. So in MEL and Maya expressions. The condition is if there's a condition, okay, then we need to open curly braces. Okay, so what I just did was control key and then use on my mouse wheel, and I'm scrolling up, and it sort of zooms in on the text size. You can do this same thing in your Microsoft Word document, and also your most internet browsers like Chrome or Internet Explorer or Firefox. If condition, then action. So statement 1, statement 2, and so on. So this is the grammar that the expression language and Mel will understand. So what we're going to do is just to substitute. So we can see that p-cube 2 translate y following, p-cube 1 translate y exactly is actually part of the action. So under some certain circumstances, p-cube 2, we're asking p-cube 2 translate y to follow p-cube 1 translate y exactly. So this condition, okay, it's something new to us. So we're just trying to word it in human language first. As long as the driver cubes translate y does not exceed 1.0, right? Then let the driven cube follow that driver cube 1 for 1. Okay, so simple enough. So let's try to find some way to translate that. So whatever we typed, I didn't hit edit, so my edit was lost. But let's type it again. If, so this condition, and then open brace, close braces. For us to make it easy for us to read, we always put a tab, so it's sort of an indentation, so that we know that. And because of the open and close braces, we know that this is all part of the action block. So now, if, okay, we're watching the translate y of the driver cube. So what's the driver cube? It is p-cube 1 driver ty. So if p-cube 1 driver ty translate y, which is the vertical, is lesser than 1, edit. So when we edit, there's no error. We've told it to do a test. So to test whether the original driver cubes translate y, is it less than 1? So let's try and move this guy. Let's try and scrub the timeline, and you can see that in our front view, we want to see whether it's following exactly. And at certain point, you can see that this small cube has stopped following. Okay, so at which point I'm going to step through frame by frame and keeping my eyes on this. So this number now, because we've selected the driver cube, it's reflecting that. So we want to see what's happening frame by frame, right? So frame 9, it's 0.863, and then the next thing is 961, so it's still following exactly. And then let's step one more frame through, and you can see that on the next frame, translate y has become 1.056, and that condition of our expression no longer holds true. So the driver cube's y is 1.056, which is already greater than 1.0, then this expression did not hold true. So it sort of stays where it was. So the last position where it evaluated was 0.961. So if we step back to frame 10, we would see it's still at 0.961. Okay, so that was last known position. After we step through to the next position, it did not change. That was because it's the last position, and our expressions only catered for if the y translate of the driver cube was lesser than 1. So now this new situation has happened, and there was no provision, and we didn't tell the driven cube what to do. Therefore, it remained the same. My driver cube, after it reaches the top, it's going to come back down and it's going to go beneath 1.0 back to a smaller value, and that's when the driven cube is going to follow along back again. So let's see which frame that is. So I'm going to select my driver cube and taking notice at what's happening on the translate Y. So again, stepping through the frames, you can see that that small cube is the driven cube is still not following, okay, but it's getting really close to 1.0. Once it falls below that, you can see that the driven cube is going to follow back again. Okay, so this 1.032 and 0.966, and it's going to catch it back on and following again. So all that kind of behavior we can achieve by using expressions. So I'm going to select the small cube again, translate Y, and with a single line, well, 2 lines, you can see that we've managed to achieve some kind of complex relationship between these two cubes, right? Okay, I'm gonna find a frame that is very close to 1.0. Okay, so this is 1.056. I'm gonna change it to 1. Okay, why do I do that? You're gonna see it in a second. Okay, let's step through that value again. 0.8, 0.9. So this is the driver cube is still not reached 1 yet. 8.9. That this next keyframe, I want you to see very clearly. The driven cube is going to go to 1.0. I know that on my 11th keyframe is going to reach, the driver cube is going to reach 1.0. Do you think the driven cube is going to follow along to 1.0? Think for a second. Okay, so now let's go back and step through and let's get our answer. So when the value of translate Y on the driver cube is beneath 1, we know that the driven cube is going to follow 1 exactly and having that same value. Okay, so now we're going to cross over the threshold to keyframe 11 and having a 1.0 on my driver cube, translate Y, so 10. Okay, so that's 1.0 on the translate Y. So did the driven cube follow? It did not. Why did it not? So let's take a look at the expression on the driven cube, translate Y again. So what did we test for? We tested if the driver cube translate Y is less than 1. So on frame 11, it's exactly falling on 1.0. But we were testing it for whether it was less than 1. So at this frame 11, the driver cube's translate Y is equals to 1.0. Translate Y's value equals to 1.0. So if I were to test whether it was equal to, I need to use this notation. It's equals equals. Okay, so this is to test. If I wanted to do a condition to test whether it was equal to, I would do this and then my action block. Okay, I can do it in one line if I wanted to, as long as I put a semicolon here. Okay, so equals to is not the same as smaller than. This condition tested true as long as my driver cube translate Y is less than 1. But once it reaches 1.0 at frame 11, this condition tested false. So it failed because equals is not the same as lesser than. So how do we test for lesser than and equals to? So that's like 2 conditions to Maya. Okay, so now you begin to see that computer scripting and expressions are not so clever after all, right? It can't read your mind. It's taking things very literally. Equals is not the same as lesser than. Okay, so this is a very important concept where sometimes it's not behaving exactly like what you want. You have to take a closer look at the conditions, what you're testing for, and so on and so forth. There is a sign, it's lesser or equals to. So this is possible, and it's totally valid in MEL and in expression language. So what we're going to do is we want to include when the driver translate y is 1, so it's inclusive of 1 and lesser than 1. So if we want to do that, let's go to the driven cube, translate y, and do lesser or equals to. So now when I'm doing that, and if I'm going to frame 11, now we know that for 11 this translate y of the driver cube is 1.0. So once we change that and we edit, you can see that even at 1.0 at frame 11, the driven cube is also snapping and being in the same position as the driver cube. So just to check again, at 11 the driver cube is 1.0 and the driven cube is following. So let's step back a few frames. Okay, this is our new expression, lesser or equals to. So frame 7, it is following, frame 8, frame 9, frame 10, and frame 11. So at frame 11 it followed, this is 1, so everything's fine. After frame 11, after it goes higher than 1, it doesn't, and then when it goes back, let's see, at this frame 31, this is 1.032, it doesn't follow. Okay, then after that it sort of falls beneath 1, so it begins to follow again. So we've come to the end of this part of the expressions video. In summary, we've talked about mainly the if statement, which let us specify a condition, and if the condition is fulfilled, we have a block of actions that we can act on. So this is a very basic configuration of the if statement, and the if statement actually comes with a few other kind of format, but I hope this is enough for you to go on for now, and I hope that you have more confidence stating and implementing different conditions and to achieve more complex kind of movements in your expressions. So I'll see you next video, and I hope you enjoy creating stuff in Maya.